First of all, thank you so much. Hello, everyone. Thank you so much, Dr. Hiba, for your invitation to do a presentation about one of the most important applications, actually, of the AI in education, which is the intelligent tutoring systems. So in this presentation, I'll talk about the general context of intelligent tutoring systems, how it works actually, what are the different components of an ITS, what's the architecture actually of the ITS. And after that, I'll present how the AI actually is blended with ITS and how the different algorithms work when we deal with intelligent tutoring systems. I'll present some examples of the ITS, existing systems that are on the market right now, and I finish by presenting the limitations and the challenges of adopting intelligent tutoring systems. So what's an ITS? Okay, by definition, an ITS is simply a software that was developed actually to interact with the student and the teachers, okay? And via its user interface, so there is always a user interface for the ITS, and the goal is just presenting intelligent behaviors to adapt and personalize the learning. So the idea of the ITS is that it offers a step-by-step support of the students during problem solving, so that we can support the students when they need help or they are in difficulty. So in other words, the ITS is simply the use of AI in education. So that's the thing that you can remember about what's the definition of an ITS. And actually, what are the motivations of adopting ITS? Why do you need actually ITS? Okay, in the universities, in the schools now, everyone is talking about ITS. I think you mentioned this in the presentation of Coursera. Yeah, they are using AI actually tools to try to personalize the content in the online MOOCs or the online courses and so on. So there are different reasons that motivate us actually to adopt the ITS. So the first thing is that this technology has proven to be effective in simulating the human cognition. So based on that, it has the great potential that this technology also will improve the teaching and the learning. So the second point is that the high ratio or the large number of population of students makes it difficult or hard for the universities to maintain a ratio or a favorable ratio between students and teachers. So the ITS actually, it will be, or it has the potential actually to help actually alleviate this problem, and we try to accommodate any number of students that we have in our courses or at the university level. So the decrease in one-to-one interaction, it's one-to-one interaction between the students and the teachers. It's a consequence actually of the large number of students that we have in our courses. And as I said, the goal of the ITS is to try to have a real-time chatbot or real-time virtual assistant that will help to answer answer the questions of the students when the students are in the need for help or support. So the grading actually is one of the most important things for the professors. Grading is time consuming, okay? And the professors actually are overwhelmed with the grading, the assignments, the evaluations, the exams. And when we don't have time, or if the grading is taking time, this will lead to a delayed feedback or giving delayed feedback to the students. And the research demonstrated that the feedback is one of the most important factors for student dropout. So if we are unable to give instant or immediate feedback to the students, we will have as a consequence a lot of dropouts for the student. And if, as I said, the delayed feedback will also lead to the consequence of disengaged and less motivated students. So the ITS, one of the goals of the ITS actually, is to keep the students engaged, keep the students motivated when they are in the learning or the course of learning. And at the end, the online or the emergence of the online learning, we talked today about the MOOCs, which is one form of the online courses. So this makes a suitable environment for the intelligent tutoring systems to help or to provide support for the student. For example, in Coursera, there are some courses with more than 40 or 50,000 students enrolled. So how to manage that? It's just impossible to have human tutors following those students. So these are the major motivations for why we need to adopt actually the intelligent tutoring systems. So back to the history, the intelligent tutoring systems are not new, so it's not a new technology. The first ITS, it was developed actually in 1970 at the University of Stanford. So that system was called Scholar, so it was the first ITS to teach actually the South American geography. And the students, after that, in 1995, the cognitive tutor from Carnegie Mellon University, it was an ITS, the first ITS actually that teach computer science and mathematics. In 2005, Auto Tutor, it's another ITS that was developed at the University of Memphis. And the same university, they developed or extended the Auto Tutor in 2018 to develop what we call the electronics tutor. So it's an intelligent tutoring system to teach the basics of electronics and electricity. With the emergence of generative AI, ChatGPT in 2023, we have a lot of ITS and a lot of systems that have been developed actually. One of this, or one example of these systems is Noodle Factory. As Dr. Hiba mentioned it in her presentation today, Noodle Factory and Tutello, two intelligent tutoring systems based on ChatGPT, and they are working very hard actually to do the pilot testing for these tools. Dr. Luay will present in his presentation a demo about Noodle Factory, how it works. So now if we analyze the situation here in Qatar, is there any universities that are using ITS? Is there any development or adoption of ITS? So it's very, very limited. Just to not say they don't have actually ITS in the universities. So the last September, the Qatar National Library, what they did a forum, and they discussed about the importance actually to implement ITS in the universities in order to personalize the learning. So, and actually, the only ITS that was developed here in Qatar in collaboration with the University of Illinois at Chicago. So it was called Collab ChiCat. So it's an intelligent tutoring system just to teach very specific topic in the computer programming, which is the linked lists. The idea of this tutoring system was to use actually peer programming, so two students working at the same time. They work on how to learn linked lists and how to implement the linked lists. That's the only research that was done here in Qatar about the intelligent tutoring systems. This is a very important point. So there is now a new ranking of the universities worldwide, and this ranking is based on the AI. So the AI not only in the curriculum, not only in the research topics of AI, but also the ranking about the use of AI in the universities. So we will see in the next or the near future that the AI will be one of the features that will be used to rank the universities worldwide. So if we want to be, or to secure a place in this ranking, we need to start from now using this AI, developing AI curriculum and so on. Okay, so in this slide, we summarize 4 experiments that have been done in 4 US universities about 4 different ITS. So the first ITS is Cognitive Tutor at the University of Carnegie Mellon. The second one, Alex, University of California, Deep Tutor at the University of Memphis, and iStart at the University of Pittsburgh. So they have their own in-house intelligent tutoring systems, and what they did experiments on this ITS in the university. So what they found at the end was the conclusion is that the students that they use the ITS had a better, much or significant performance compared to those who didn't use the ITS. So this is just to showcase that the use of ITS could be or has the potential to increase the learning for the student and to ensure high grades also for the students. So I have some statistics about the use of AI and ITS in the universities and also in colleges. So these statistics are in a randomized order, but the idea is just to give you how the AI is used by the students, by the teachers around the world. So we start by the number of publications in this topic. So we have more than 3,470 scientific papers published in the topic of intelligent tutoring systems. So it's a very hot research topic. And there is a venue, international conference on intelligent tutoring systems for those who are interested, for example, to publish or to see what's happening actually, what's the recent development of ITS. So these publications received about 60,000 citations. So as I said, it's a very hot research topic actually. Let's start by the statistics. So we have 43% of the US college students admit using AI, like ChatGPT, for example, for studying, which is not surprising. Our students also, they are using ChatGPT in their learning. They are using ChatGPT maybe in the assignment and so on. 50% of teachers use AI themselves for lesson planning. I don't know the percentage here of our professors, our faculties, if you are using the AI in your lesson planning or not, but we can do a poll to maybe count and compare it with what we have as statistics. This is very good point. AI grade prediction. I'll come back to the slides. What's AI grade prediction? So AI grade prediction technology was able to identify and save over 34,000 students from failing. So this is one of the most important functionalities of ITS, is to predict the performance of the students. For example, we see now the students, when we arrive to the midterm, we see they come for the dropout. Okay? And if the university has this system, we are able to predict the student who will drop out, so we can intervene, we can help these students, we can do, as I said, a priori interventions for these students so that we can save them and they continue, they can succeed at the end. 67% of the UK secondary school, this is secondary school, use AI for homework and assignments. So this is secondary school, so the universities, I know the percentage is much higher. 35% of Swedish university students, they use AI regularly. So not only in the assignment, not only in the evaluations, but they use it also in the learning. 68% of students that use AI believe that the AI improved. The AI here, the intelligent tutoring system, so they improved their grades at the end, which join exactly the 4 experiments that the universities did before. This is very important. You know, the parents, they are not happy with their kids. So 75% of the parents think that using AI writing tools is a form of cheating. So they are not happy with the use, for example, ChatGPT to write a motivation letter or ChatGPT to write an email, something like that. Okay, let's continue with the statistics. 90% of the students who study with ChatGPT find better than using a tutor. I don't know how you perceive this. It doesn't mean ChatGPT will replace the tutors, but they found that it's really helpful, actually, in their learning. So don't take it personally, you know. Okay. This is also important for the platforms. Okay, maybe Coursera, you are already, you know, ahead with this with these AI tools. Nearly half of the learning management systems, the LMS, D2L, for example, Blackboard or Moodle, so they will incorporate the intelligent tutoring system, so the AI, actually, in 2024. Adaptive AI learning systems can improve the test scores by 62%. We'll arrive, I'll discuss in the next slide what does it mean, adaptive and personalized learning. The AI marking tools can help teachers spend 70% less time. So this is, I think, one of the important also things. And Dr. Saif, you asked the question about the grading. So I think the auto grading is one of the functionalities that is really it's a must, actually, for the professors. So the 70% time that we save, we can spend it in research, we can spend it maybe in curriculum development and so on. 60% of the US college students say that teachers, and this is also very important, okay, teachers haven't advised them on ways to use the AI ethically and responsibly. And this is also a very important point. So when we use the AI, or when our students are using the AI, using ChatGPT, we need to explain them what are the ethics of using this. Okay, in terms of IP, in terms of confidentiality, in terms of the privacy, and so on. We ask always the question why ChatGPT is actually storing or recording our conversations, or the history of conversations. So this is just, as I said, statistics to give you an idea about the use of AI in the colleges and universities, and what's the trend, actually. What's the trend of the AI and the intelligent tutoring systems in the education in general. So in this slide, we present what are the domains, actually, that are where the ITS is making a notable contribution. So the first domain here, as you can see, is the mathematics. So the overall ITS, actually, they have the mathematics tutors, or they have the virtual tutors to learn the mathematics, which is obvious, actually. The mathematics is the domain where the critical thinking and the problem-solving skills are very important. And the students, they usually struggle in these courses. So the ITS, following the cognitive science, you know, strategy or theory, we divide the problems into sub-problems, and we try to help the students actually succeed in their courses. So followed by the language, okay, learning languages, foreign languages. There are a lot of ITS also for on how to do or how to learn languages. And after that, science, and the 12% is the computer science. The other fields are a little bit limited in terms of ITS. It's not because we don't want to develop in these fields. Sometimes it's very hard, okay? For example, in the medical field, developing the ITS, it's not an easy task. Okay, so now we understand what's an ITS, what's the goal, what are the advantages of ITS. Let's go deeply into how it works, actually, the ITS. So the ITS, usually all the ITS, they are composed of different models, okay, as you can see here. So we have a pedagogical model, we have domain model, we have student model, open learner models. These are the 4 main components. In the next slide, we'll explain each model, what it does. And these models, actually, they interact with the user interface, okay? All the students, they interact with these ITS, these artificial intelligence tools using this user interface. So the user interface, actually, we collect the data from this user interface, we analyze the data, we send immediate feedback to the student based on the data that we analyze, and we can personalize and adapt the learning, so we can recommend the content for the student according to his performance, according to his preferences. And there is here, as you can see, the 3 models. The output of these 3 models constitute the input of this block here, which is the AI algorithms. And there is here, as you can see, there is a loop in this side, and there is a big loop in this side. So in this side, the loop is called the inner loop. So the inner loop, what it does, from the user interface, we collect the data, we analyze it, and after that, we come back to the student model and the domain model so that we update these models. And we will come back to the inner loop. What's the importance and the goal of this inner loop? Okay, and once the inner loop, as I said, the goal of the inner loop is just to help the student realize the activity, and how the activities actually are organized in the ITS. They are organized in step by step. So each activity is subdivided into different sub-activities, and the ITS for each activity or for each sub-activity, the ITS, what it gives or it provides some hints for the student, so it has always an immediate feedback. And once the activity is completed, terminated by the student, the ITS, what it does, it will just prepare the next activity for the student. And this, it constitutes what we call the outer loop on ITS. So, okay, so let's dive deeply into the different models, okay, what each model is doing actually. So the first model is called the domain model. So when we say the domain model, this means the topics, okay, that we are teaching. If we are in computer science, that's actually the domain. So it represents the expert knowledge. So here the expert knowledge is you as teachers, you are delivering the course. And, and it's also, it represents what we call the what to teach, okay? So that represents actually the content that we are teaching. So it contains also how the problems are solved, actually, what are the definitions, the procedures, and so on. And it contains also the set of skills, the set of knowledge, and what the ITS actually should do with the content. The second model is called the student model. So the student is our learner, so we need to understand all the personas of the learner. Or it's called also the home to teach. So it represents the skills, or it represents actually the skills and the knowledge of the student. And here in the student model, we are also interested not only to the skills and the knowledge, but we are interested also to the cognitive, emotional, motivational, and all the psychological states of the student. For example, we need to understand if the student is happy, is bored, is annoyed, and more specifically, if the student is confused. So we need to intervene when the student is confused to remove that frustration and try to allow the student to move forward. The pedagogical model, when we say pedagogical, is the way to teach, okay? What are the strategies, actually? So it's the how to teach, and it includes also the teaching strategies, the pedagogical knowledge, and the decision on how and when to interact, actually, with the student. The last component is the user interface, which is very important. The user interface should be well designed so that we allow the students to easily use and interact with the interface. So the interaction could be using the speech, so we can talk to the interface, and this is more conversational, called conversational ITS. We can write or chat with the ITS, and we can also use the interface directly, drag and drop, and clicking, and so on. So in all this, what is the AI? So we talk about modules, this is more software, but what is the AI behind all this? So the AI is this part, is the algorithmic part. So as I said, the 3 models here, the domain, the pedagogical, and the students, all they feed the AI algorithms. So let's go and see how actually these AI algorithms work and what we can develop as functionalities. So the first functionality that we can have in an ITS is what we call the emotion and sentiment detection for the student. So we are interested, as I said, to the student when he's happy, the student when he's bored, when he's annoyed, when he's confused, so that we need to understand the behavior of the student, and after that the content will be personalized and adapted according to the emotion of the student. So if the student is not happy, don't just go over the steps and continue the learning. So we need to come back, we need to try to relax the student, and there are even some gaming, so they are introduced in the ITS to alleviate the stress for students. The user profile or the student profile is also another functionality that we need to develop, okay, to understand the skills, the knowledge of the student, and all the performance of the student, the history, the preferences, the learning styles. So all these are represented in what we call the learner profile. One important advantage of the ITS actually is how to personalize the learning. So how to personalize the learning, we need to collect the data about the student performance, okay, about the level of the student, about the learning style, about the preferences of the student, and based on this, the algorithm or the AI behind, it will be able to adapt the content, will be able to recommend the content to the student according to all these, to all these features. Real feedback for the student, and here I come back to the inner loop. So the inner loop, as I said, the goal is to always have an immediate feedback for the students. So if the student is stuck in one of the steps, so the system should intervene and should send the feedback or the hints actually for the student so that they can continue their learning. Great prediction actually, and I came back to the statistics that we showed. So the university that did the experiments, they were able to save 34,000 of students from failing. And this is actually the goal here. If we are able to predict the performance of the students before the midterm, this is something that we can implement even at UDST. So if we are able to predict the students that they have poor performance, so we can intervene, we can provide more support and more help to those students. And at the end, the auto-grading, which is a functionality, it's a very important functionality for the professors. Now the ATS, all the ATS practically, they have the auto-grading. But not only the auto-grading. As professors, we don't need only auto-grading, we need also the tool that will help us to generate the assignment, generate actually the quizzes, and so on. So this actually summarizes the different functionalities that we need to have in an ITS or a complete ITS. So in one of the published research about the factors of student dropout in the universities, they found that the feedback is the most important factor. So if the student don't receive a feedback, this is one of the triggers actually of the dropout. And here I come back to the, as I said, to the inner loop, how to come back? Okay, yeah, sorry. So as I said, I come back to the inner loop in the ITS. The role or the goal of this inner loop is to have always an immediate feedback to the student. So in a step-by-step solution, at each step, the ITS, what it does, it gives the hints, it gives also the feedback for the student, and the student, they can learn from their mistakes, and they can improve also their learning. So here I'll discuss some examples of the ITS that exist right now on the market. Cognitive Tutor, as I said, it was developed by Carnegie Learning. Sorry. Carnegie Learning is a startup developed at Carnegie Mellon University. So this startup was founded by researchers in cognitive science, computer science, and education. One of the researchers of this startup is John Anderson. So for those who work in the cognitive science, John Anderson, he's the one who developed ACT-R cognitive theory or cognitive model. ACT-R stands for Adaptive Control of Thought Rational. It's a cognitive architecture that's used to simulate the human cognition. And what they did, they included actually this ACT-R in the cognitive tutor. The idea is that the cognitive architecture simulates the human cognition and the learning. So it fits exactly with the learning of the students. So when the student, they are overwhelmed with the information, the consequence will be sure the curve of learning will decrease. So what they did actually in this, it was for the CS and math, so computer science and mathematics. And what they implement actually in this was the instant feedback. It was the first ITS where the instant feedback was done using this cognitive architecture. Electronics tutor, as I said, for the engineering department, it's an ITS to learn the basics of electricity and electronics. And it was the first ITS actually that was developed in 2018 for content recommendation. So based on the performance of the student, we can recommend what's the next topic to be learned. Cogni is a new ITS also that's developed in Los Angeles in US, and it's a virtual learning assistant actually that's designed to and optimized for educational conversation. So it's a start in the high school for mathematics and computer science, and after that now they generalize these ITS into the universities. So they are working now on experimenting also in the universities in different domains, not only computer science and math. So SysTutor, it's a very specific ITS. I mention it because sometimes the ITS is developed for a very specific topic. So for this one, it's an ITS that is developed by the CMR Institute of Technology in India. It's an ITS to just learn how to interpret the seismic data. So it's in physics, but seismic data, it's one of the, it's the goal actually of this ITS. Node Factory and Tutorlo. So Dr. Hiba mentioned these two tools. They are new tools. They were developed just last year in 2023 and still in the testing process. So Dr. Luay will present in his presentation a demo of how Node Factory actually works. But the two tools, they are based on ChatGPT. The last one, Radar Math. So it's a Chinese ITS. It's a very good ITS to learn the basics of mathematics. And why I mention this, because this ITS is based on a very hot topic in research. It's called the knowledge graphs. How to represent the learner profile in knowledge graph, and how to use the deep learning algorithms actually to recommend the content, to model the user profile, and to do automatic grading. So here I'll show you this video. The focus of this video on Radar Math, it's not just a publicity, but it's as I said, how they use the knowledge graphs to represent the learner profile and how they do the deep learning algorithms for the auto grading.
After logged into Radar Math, the first thing comes in sight would be a personalized knowledge graph with the current user's cognitive information. Different size circle nodes in the graph represent different leveled math concepts. The knowledge granularity gradually becomes finer from the first level to the third level. Clicking on any third level node, you would see all the corresponding fourth level math concepts below it. The colors of the nodes represent the learner's current knowledge status, that is, the mastery level on that concept. Specifically, green, orange, and gray corresponds to mastered, weak, and unlearned states, respectively. The estimated probability is calculated based on a novel knowledge tracing model, which integrates the information from both cognitive relations and topology structure derived from the knowledge graph in math. Moreover, the deep learning model in artificial intelligence is also adapted to build a more accurate knowledge tracing model for fine-grained concepts in math. The lines between nodes in the graph represent different cognitive relations, including inclusive relation, prerequisite relation, etc. By leveraging on the probabilistic association rule mining or other machine learning algorithms, such relations can be automatically labeled and identified on large-scale online assessment data. After manually verified and modified by the domain experts, the results could provide reliable cognitive relation information to construct the desired knowledge graph for math. Based on the constructed personalized knowledge graph, Radar Math could recommend to learner the concepts she needs to learn. Radar Math could make accurate diagnosis on the current weak concepts and trace its root causes. For example, a weak concept might be caused by its prerequisite concepts. The system could identify such root causes and accordingly help the learners to overcome her learning obstacles. According to the system recommendation, learner could enter the specialized learning page by clicking on the corresponding concept. There are high-quality micro-lectures constructed by discipline experts. After watching the micro-lectures, Radar Math would recommend the corresponding online exercises, all with the standard answers and interpretations. More importantly, an automatic grading function is also implemented in the system to alleviate teachers' workload on grading. For the semi-open and text answer questions, Radar Math provides the auto-scoring service, where the deep learning model with the attention mechanism is introduced to construct the grading model. For the formula answer questions, Radar Math utilized the equivalent regular expression matching to achieve the auto-scoring on different forms of answers. Using the auto-grading results, the system would also automatically update the real-time knowledge status of concepts in the knowledge graph. After the weak concept and its prerequisite concepts have reached a high mastery status, the system would guide learner to continue studying the successive concepts. Accordingly, Radar Math would provide each individual learner with a personalized learning path. And the data would be used to generate the comprehensive report in a visualized form for individual learners.
So sorry if the video is a bit longer. It's 3 minutes, but it gives an idea of how to use this actually, the knowledge graphs to represent, as I said, the learner profile and how the deep learning algorithms are used for the auto grading. So as a technology, you know, there is always limitations and challenges, and our role is to present actually those limitations so that we know what we are dealing with. So the first thing is about the first challenge or limitation. It's not a limitation, it's a challenge actually, or a risk is about the data privacy and security. So in these systems, we are collecting the student data, and this data is stored somewhere on the cloud. So we need to make sure that, okay, the data is encrypted, okay, there is confidentiality and the privacy that's always ensured when we store this data on the cloud. So the second point is about the bias and the fairness. So as I said, there are deep learning algorithms behind or artificial intelligence behind. So the bias could come from the data that we collect and could come also from these algorithms. So we need to make sure that the data that we collect is representative actually of the pool of the student, so that when we generate or recommend the content, the content is actually reflecting the reality of the student. Fairness also, about this is more about the auto grading. So as a human, when we correct the assignment of the students, we know that there are different methods on how to get into the right answer, but the deep learning model, for example, is straightforward. If you get it as it was prescribed, you get the mark, otherwise you get 0 for the exercise. So this is also that needs to be taken into account when we adopt this technology. The integration with the existing systems, so there are some ITS where it's hard to integrate with the systems that we have, or the LMS that we have. For example, we are working with D12, so it's good to have an ITS that will be easily integrated or seamlessly integrated with the platforms. Training and support, so these ITS, we need to train the student, we need to train the faculties on how to use it, and also the support, specifically when we have outsourced ITS, so sometimes the support, it's not always, you know, available, so it's something that we need also to be careful about. So when we develop this technology, actually, we try to make the students more autonomous in their learning, but at the same time, we are like pushing the student to work alone, and there will be some kind of social isolation, actually. So the student on campus, we know the real life, the students are interacting with the professors, they are interacting with each other, and here we need some awareness campaigns, actually, on how to be always attached to the professors, attached to the friends, and so on. The lack of communication, this is a consequence actually of this social isolation. So we need, as I said, the students need to be aware that the communication is very important, and they should be always connected to their peers. The cost of implementation of ITS also is something that we need to take into account. So the development of ITS, when we talk about the development in-house, so it's usually, the cost is usually very high, and it depends also on the functionalities that we need. We need the resources, we need experts in AI, we need experts in design, we need experts also in education. So this actually, it constitutes a high cost for developing these systems. As I mentioned it in one of the slides about the topics where the ITS are making notable contributions, there are some domains where it's very limited. So we don't have ITS for those domains, and this is one also of the limitations. So sometimes it's very hard to develop ITS in these domains. The evaluation of ITS also is a very important point. So we need to ask the questions about what's the size or the sample size of the student that need to be involved in this evaluation. What are the levels of student students that need to be involved in the experiments. Should we take first year, second year, third year, fourth year? Should we take also masters to validate this, these systems? And should we include persons with disabilities also to validate this system? So all these are very important questions that we need to ask when we evaluate or when we arrive at the evaluation of intelligent tutoring systems. Ethical considerations, because we know we are collecting the student data, so we need to have the consent of the students when we start collecting the data. And now in the Western universities, what they do during the admission process or the online applications, there is always a checkbox where the student need to agree that the data could be used to improve the teaching, could be used for research purposes, and this is something that's guaranteed to the university, for example, that we have always the consent of our students before to proceed with any research project, before to proceed with any analysis or data analysis, the data analysis for this kind of projects. Dr. Hibe asked me about the difference between, between Tutorlo and Nodal Factory, right? Yeah, so one of the, when we did the pilot testing for Nodal Factory, for example, we were using, we have only the student are exposed to a chat, so they ask the questions about the material. But in Nodal Factory, it was very limited in the sense we cannot, the student cannot read, for example, mathematical equations, we cannot read images, videos, we cannot even read data in tables, so it was very limited. Compared to Tutello, it's based on ChatGPT 4, so we are able to read mathematical equations, we'll be able to read videos and transcriptions and so on. So this is so far what I know about these two systems. So this makes the end of my presentation. So thank you so much for your attention. I'll be happy if you have any questions. After this, okay. Thank you.
As silly as this was, as very complicated as this was. The stuff Dr. Belkacem was talking about was actually trying to, decades and many, many hours of people trying to do what we just did, but at a deeper level. And that's basically what I did. I wanted to make a choice, and we interacted. And if I get the time, I don't know if you guys give me the time, we can sit down and talk to everybody here and ask them, why did you choose, why did the majority choose red, or why did some people choose black, and some people didn't vote at all? So there's meanings attached to these things. And these meanings will take some time to get into. So just remember this, this activity. We'll come back to it towards the end a little bit. What I'm going to discuss today is basically talk about how the teachers interact with this at the classroom level, so at the grounds level. So Dr. Belkacem talked at a very high level and me somewhere in the middle. And so now we're going to connect the middle to the ground level and what happens in our offices and with the students. So there's many ways we look at ourselves as teachers. And I added the music just to add some ambiance here. So one of the things we look at ourselves as self-image is that we plant seeds. Another one we do is we're a burning candle, and we burn ourselves to, help the students continue, depending on the workload, of course. And we also look at ourselves as we help the students metamorphose into something that is their potential, their full potential. And another one is we look at them, us going, sorry, I've trained it a little bit, but, okay, now. Okay, there you go. So we also teach the students to grow and move into life. And one of the things I couldn't help myself to put in here, we also look at ourselves at a much, much deeper level as teachers, in the sense that we help students become fully human. Again, I don't have the time to get into that definition per se, but just think about it. What does it mean to be human? So, what we want to look at, and this is given all the stuff that we look at it in terms of our self-image, in the end, when we're sitting in our classrooms and we're discussing with the students, we do 3 basic things which have been reiterated throughout the talks today. The first one we do is delivery. The second one we do is, what's the second thing we do? Assessment, very nice. There's a lot of energy. What's the last thing we do? What's the last thing we do? Evaluation or feedback. So these are the 3 steps that we actually, this is what we do day in, day out. Delivery, assessment, and feedback. So Dr. Belkacem, when he was talking about the intelligent tutoring system, the intelligent tutoring system actually helps us do all 3 at somewhat of an enhanced level. That's what it does. So, and again, I don't want you to forget the first activity that we did with the tie, because we have to tie it all together later on. No pun intended. So the first thing we do as teachers is we upload our material. So then you just simply drag and drop your material. We've been doing this in D2L for quite a bit right now. But the ITS has that extra step that Dr. Belkacem was talking about, where it actually now sees how the student is interacting with the material that I uploaded. It's not just a one-way interaction. So don't forget that inner loop business he was talking about. The other thing, once you upload everything, what happens is the AI takes over in the language that he explained, and then it starts creating something called a knowledge base, and filtering the knowledge base, breaking it into things like Bloom's taxonomy, everything from very low Bloom's taxonomy to very high Bloom's taxonomy, and builds the personalized path. So it does all this stuff in the background that he was talking about. And what we end up with is learning outcomes, quizzes, and all these 3 are encapsulated in what, of course, is the most important voltage of education, is engagement. So you guys know this already. Like, if somebody's not paying attention, no matter what I do, they're not gonna receive anything. And so the ITS actually gives me that extra edge as a teacher to grab their attention and engage them a little bit more personalized. So this is one example. So what it does is it actually engages it through chat. So talking to the student, and right now we haven't talked about future of ITS per se, but right now a lot of it is text-based, but slowly we're going to see voice and picture and stuff, and we kind of see this a bit already. So it chats with the student and gets to know the student, just like maybe you're talking to someone and you get to know them. You get to see what they like, what they don't like, their body language and so on, and you actually react to that. So in that sense, it actually also helps with the delivery. So the delivery itself helps out. I mean, again, we're all here, teachers and so on. You all heard of assessment as learning, right? Or heard of this before? So it actually does the assessment as learning while it's chatting, which is quite interesting. I wasn't looking for the word interesting, I forgot which word I was looking for. So what I'm going to show you, say again? Yeah, that's the word I was looking for, impressive. So what I want to show you now is actual examples of chatting with the system, and just to see how it is. And it's pretty scary, because after a while you actually don't think you're dealing with a machine. You think you're actually talking to a human being. So let's see. So this is a chat teaching a student how to solve this problem. So I don't know at the back if you guys can see the writing or. So the student is going to say, can you please give me the answer for this? And it's a rude student, by the way. It's a magic exclamation mark. So the system actually says, okay, let's try to actually solve this together. What would the first step be? And it reacts to them that way. So the student gives up very quickly and starts typing some sort of an answer. Now, again, this is very, very impressive language, because it's talking about distributive property. It actually realized that the student has an issue with the distributive property. I just want you to close your eyes and think about this. A computer system is able to actually figure out from an interaction that the distributive property is missing. That's quite a lot of programming. So it can go to that level. So I chose this example mainly because this is not a simple equation, you got the number wrong, I can compare two type of numerical answers. No, this is the meaning of distributive property. Just like right now, I don't know what the meaning is for you guys when I put a red tie on versus when I put a black tie on. I'm a guy, so we only have 6 colors, huh? So for me, this is red. So I'm a human being, not a human crayon. So what does it mean for me to wear red? What did it mean? Just think about it. Can you program a computer to see all the cultural nuances, the visual nuances, the light, the shade, the shadow, and come up with what you guys told me, no, put this on. This is very similar. The distributive property is a very, very abstract idea, when you think about it. And again, when I was reading this, I was like, how did I learn the distributive property? That's a message we're going to come visit again. How did I learn it? This is another one. So this one, it's actually, the student is bored or confused, and the student says, look, I don't want to learn this. And so the student the system says, what is relevant to you? I can show you why this is important. And so this was me. I'm a soccer player, or I used to be a soccer player. They used to call me Crazy Legs when I used to play soccer. Now they call me Roundabout. So it actually asked them and told them that, listen, I can tell you, since you like soccer, I can tell you this is how this equation is relevant to your interests. Again, think about this. This is very impressive. Like Dr. Belkacem showed all these lines being connected. I could have said anything. I could have said, I'm trying to be professional here, but I could have said water polo, for example, and it would have given me something on water polo, very specific stuff on water polo. I don't even know how to spell polo, by the way. Another one, so I showed you 2 math examples. I want to actually show you now a debating example, where the software will debate with you. So not just engineering and math, but this one, the user says that I want to debate a topic. So we picked the topic of debate. It's a very American topic, so should the government cancel student debt? I don't know if I gave it here, people will be like, debt? What are you talking about? We don't even have that word in our vocabulary in this country. Alhamdulillah. So he says, okay, can you give me your points of view? And now the student is going to type, these are my points of view. And the system will reply back. Again, I could have picked any other topic. So the system is connected enough, or with all that inner loop business, it actually builds this stuff so fast that it actually interacts with you and gives you the impression that it's actually interacting with you personally. So again, just imagine the applications of this for our students. So I contemplated whether I should put this in for this long or not, but I wanted to show you that the answer of the student is so random. As a programmer, I cannot program every single response of people. Like it's not practically possible. But again, the system is connected enough to understand the meaning behind what the person is saying and reply back. I don't want to use the word intelligent, but reply back in a meaningful way, a little bit more than intelligent. And so it said, okay, so since you're arguing this and we're debating, again, we go to Dr. Belkacem's persona business, this type of persona, and it actually gave him a rebuttal. And then it said, okay, now give me your other side. And this can go on for quite a bit, and it's very impressive. One of the things, so the video is pretty long for this one. It's like close to 3 minutes. But if you go through the English, you can tell the system is actually now being very adversarial, just from the language. And so it's actually choosing and using language and that communicate that the system is quote-unquote passionate about a topic. I don't know if you guys can imagine the system's like, I can just imagine someone like me, I'm dealing with something like this, eventually I'll just like hit the computer or something. And because I forget that this is a machine and it's just talking to me and telling me, man, listen, I don't think you're right. What about this? What about that? And I'm like, oh, okay. Oh. So again, very, very close to human interaction. I'm not going to get into details with this. We're all teaching adults here. The system reads off adult learning very well. So, for example, where's the one I'm looking for, which is my students say the most? My students learn best just before the midterm. Like, man, there's a midterm? Okay, let's learn, The assignment is due tomorrow. I get messages at, 12 a.m. at night. Sir, I'm working on the assignment. And they ask questions that are brilliant. I never even thought of it. I'm like, where was this in the 3-hour class, man? So adults, they have stuff in their heads. We're thinking about stuff. Like right now, we're all thinking about lunch. So after lunch, there's going to be a lot of questions, good questions. So not a solid study like the ones Dr. Belkacem presented. Something that was done in Singapore at Institute of Technical Education, very quick. In terms of 9 months, they had 24 lectures with 26 classes, and these are some of the results. So you can see the numbers speak for themselves in this way. And again, I really focus just in the chat and how the chat interacts in real time. If we look at Dr. Belkacem's, one of the biggest things that, again, we're going to talk about this later on in advising, predicting students' outcomes later on so I can intervene earlier, you know? And it's not that we don't care, it's just, man, it's just a matter of scale. It's a matter of scale as the college grows, which speaks for itself. I need to have a tool to deal with that growth. It's just, again, it's just human nature. You know, as your family grows, you need a bigger car. As your clothes grows, you need, you know, pants with elastic bands. So same thing. As we grow, we need to be able to sustain that growth. Okay. So in conclusion, in terms of students, we have students, personalized student engagement. In terms of teachers, we have quite a bit of productivity and more meaningful productivity as well. So I don't have to chase 40 students advising and figure out their attendance and so on and so forth. And I have a tool that can actually pinpoint and help me figure out the 5 students that are in most danger, and I can intervene. And I can intervene at a human level. I can actually get to know them personally, maybe tell them anecdotes. If somebody has issues with anything at school, with anything at the course or something, I can actually go to the student and I can connect with them at a personal level. Back to this. So again, I want you, before you leave here, I want you to remember 2 things from this whole ITS business. Number 1 is the ITS computer that communicates with human beings and interacts with human beings. If you reflect on human interaction, it's a very, very deep process. It's a lot of stuff happening. So it's being built by a certain, with certain assumptions. And I feel one of the things we should do, especially in the School of Computer Science and so on, maybe we can have our own people build and contribute to this thing, so we can also use some of our own assumptions into this technology, okay? The other thing I want to reflect in is that the amount of computations that human beings do to interact with each other in terms of body language, raising an eyebrow, I don't know, the color of a tie. Just put all this in the cultural context, the smells. Like, we don't even talk about this stuff. But think about this, and next time when you're interacting with each other and with people, just kind of realize how deep this thing is, in the sense that this ITS, yes, it's a technology that's going to help us serve and grow, but it's also a very good technology to help us reflect how we as human beings interact with each other and how deep it is, and maybe we can be a bit more merciful with each other, a bit more slow in terms of I make a judgment versus another person making a judgment, and these meanings that keep flying out from everybody. And just reflect on it with us in terms of our collegial interaction, also with the students. So that's what I want to say today. And thank you very much.
Can I bring this to the back picture?
Yeah.
Please have a seat. Thank you so much, Dr. Belkacem, Mr. Luay, for this great presentations. Honestly, I learned a lot. I noticed that the picture had a woman and a man talking to each other. The man is trying to decode what the woman is trying to say. It reminds me of my interaction with my husband. He's like, what are you saying? You know? So I see a future in this ITS system, also between, the interactions between partners. So hopefully, it would ask questions like, how do you make your wife happy and your husband happy? The other second point is, less emails for us. I receive emails at 12 o'clock at night, and they're like, did you read my email? I'm like, when? He's like, at night. I'm like, well, I have a life other than my professor work. So questions for Mr. Luay and Dr. Belkacem, please. Any questions? Yeah. Where did you buy the tie?
I 3D printed it.
Yes, Dr. Heba.
Dr. Belkacem and Mr. Luay were heavily involved in the research and testing of different ITSs to hopefully implement in the new academic year. So, considering that you did all this testing with us, what kind of features do you think that we can incorporate, in our ITS if we speak about UDST? Because I know each college has different learning needs. So, what can you recommend as features for our own ITS?
That's a good question, actually. So if I come back to what we tested, for example, Noodle Factory, it was a very limited ITS, okay, in terms just how to read text data. So if we have, for example, mathematical formulas, if we have images, videos, the system wasn't able to read that or to help the student in that. Compared to Noodle Factory, so Tutello actually, it's more strong in terms of reading the different types of data. If we have images, videos, or mathematical formulas, we are able to read that. So in terms of functionalities now, as I said, for example, the student dropout or the prediction of the performance, this is one of the most important things at the university. At the midterm, we receive the students, they come for the drop, they want to drop, okay, how to help us. If we are able to predict the performance before the midterm, I think this is something that we can intervene, we can help the students so that they can receive the right support before we arrive to that stage of dropping out. And the statistics show that, as I said, in US, with this feature, they were able to save more than 34,000 students from dropping out. So this is, I think, the most important features, in addition, for sure, to the adapted learning and personalized learning.
Thank you. Please. Dr. Fred.
Yeah.
Oh, no, come on. Feminists will not agree with you here.
Yeah. Okay, so thank you for your question. Actually, the development of ITS, as I said, in some domains it's difficult. It's not because we don't have the material to develop that, but just because it's very costly, actually, for example, to develop in the medical field. And I think this question raised also today in the panel, how to do the labs, for example, in the medicine. So this is something very tricky to do it. We can have some kind of virtual reality introduced in the ITS. We can do that. There are some research on how to do that. But how to ensure the labs, how to do more practice, this is something that we need to do it on campus, for example. So that's the only reason, but it's feasible. Yeah.
Thank you. Mr. Jarrah?
Yeah, very informative. And a couple of questions. We recommend peer-to-peer tutoring right now in a lot of our courses. Well, I'm very interested in the ITS mainly for the courses where we have high withdrawals, high failure rates. So this is where I think I'd like to see us do some work with those courses in terms of phase one of rolling out ITS. But on another point, I also teach business economics, which is one of those high fail courses, and we do teach in an applied learning domain. So I don't only teach my students about the concepts, I ask them to apply them. So for instance, if I'm teaching monetary policy or fiscal policy, when I assess them, I give them questions like, how would you advise the minister, if there was a certain situation? So how, on that higher level of blooms, analyze, apply, how does ITS deal with that in courses like economics? I can see the math because the math is, you can show them how to, by step, but when they're doing these high-level blooms with analyze and, the critical thinking piece, how well does ITS address that?
Yeah, I have to stand, okay, to answer your question. This is very important. So actually, as I said, the intelligent tutoring systems, the domains where the intelligent tutoring systems, they had a notable contribution was the mathematics. Why? Because we need the critical thinking, we need some problem solving skills, okay? And the idea behind the critical thinking and the problem solving is how to divide your problem into sub-problems. Okay, and this is, as I said, it's rooted in the cognitive science, actually, how to solve the problems in our mind or in our brain. Usually we divide the problem into sub-problems, and after that, for each step, we need to put the student in a situation where they are not cognitively loaded. So if you give a lot of information at the same time for the student, the student will end up by being confused. So to avoid that, we need to go step by step, and for each step, we need to give feedback to the student. So based on this, the student will learn, okay, in the different steps with the different hints that the ITS will give, so that we will be able to finish by realizing the activity with a big confidence for the student. So that's actually how to deal with situations when we have this problem-solving and critical thinking skills needed for the ITS. And it works for economics, because it works also for computer science, for mathematics. So in all the domains where the problem-solving skills are needed, the ITS, they have more, let's say, notable contributions. So they prove they are effective on how to deal with these situations.
Yes.
Does it answer your question?
I want to finish on time, but Dr. Heba has a comment to say.
I can't resist but to answer you, Dominic. So from an operational side, because you mentioned high student or high failure rate, we're starting with MOOCs and the ITS with the critical courses, what we call them critical courses. High student dropout rate, high failure rate as our pilot courses. So just to let you know that we're starting with these, and once we see fruitful results, then we extend to other courses. Just a little comment.
Thank you so much.
Can I just answer one?
Yes.
Thing? So I wanted to attempt an answer to this one. So you guys know, again, as teachers here, when we talk about Bloom's taxonomy, we have three Bloom's taxonomy. Right? We have the cognitive, the affective, and the psychomotor. Right? I'm not talking Chinese, am I? Okay, so ITS is very, very good at the cognitive side. Amazing. At the affective side, is very good at the very lower level of affective. And when it comes to the psychomotor, again, it's very good at the lower level. But when it comes to the higher level, where, for example, like an engineer would need to do welding, for example. The ITS at this moment, I don't know what the future is going to hold, but at this moment, it obviously cannot allow you to do the welding process, because I need to worry about smell, weight, like I need to worry about real life variables. And so it won't allow you to do that. In terms of economics is at a certain level a mix of affective and cognitive at a very high level, because what is a good advice from one side might be detrimental to the other party on the other side. And so the ITS is not good at linking also Bloom's taxonomy pyramids. So like Dr. Belkacem said, we're gonna have to kind of break that analyze this economic, give me advice on this economic formula to a little bit more lower level. But we can use it for these things, but we still haven't have the technology for the other areas.
Thank you, Mr. Luay. Thank you, Belkacem. I would like to celebrate all of you for being in this room today and all the things that we learned together, and celebrate the fact that we finished the first half of the day on time, so first time. We will now be pausing for our lunch break provided for you outside the auditorium. Just a gentle reminder that the afternoon session will be breakout sessions. Please refer to the rooms flashed on the screen. The afternoon sessions will start at 1 p.m. sharp. Thank you. Please, lunch break. Enjoy your lunch break. Thank you.